This video review covers our introductory unit in ISTEM. Okay. First question, which of the following quantities is a fundamental quantity? Okay. It would be time, right? Notice the other three are all derived quantities. There's some combination of the fundamentals of length, time, and mass, right? Specifically, speed is length over time, density is mass over length cubed, and volume is length cubed. Okay. Which of these quantities has the units of centimeters squared? Also could be said as square centimeters. Right? And that would be area. All right, pretty straightforward. Take one length dimension times another. Unit conversion. How many millimeters is equivalent to 0.045 kilometers? Okay. Correct answer is 45,000. Show it a few different ways. If you use your label chart method here, 1,000 meters in a kilometer, 1,000 millimeters in a meter, wind up fully multiplying by a million, which leads to 45,000. You could also think of it as 6 jumps between kilo to milli. And because we have a smaller unit, the number is going to get larger. So when we bring that all the way across, we get 45,000. Okay. What does the number 78,930 look like when in scientific notation? Okay, be the last one here, 7.893 times 10 to the fourth. You would have to slide that decimal point 4 times to the left. And this number is a quite large number, so the exponent will be positive. Okay. Convert 40 miles per hour to feet per second. Please note that there are 5,280 feet in exactly 1 mile. Okay, here the correct answer is 58.7 when rounded to the nearest tenth. If we start with 40 miles per 1 hour, notice what's in red here is the value we're starting with. All the ones in purple are conversion fractions, right? We put the mile in the denominator, so those units cancel. In 1 hour, that's equivalent to 3,600 seconds. If we do 40 times 5,280, take that result and divide by 3,600, we arrive at 58.6 repeating feet per second, rounded up to 0.7. Okay. Dial caliper reading. In the image below, what is the correct length measurement? Okay. It would be 0.213 inches. If you zoom in here on the caliper, notice that the edge is between 2 and 3/10 of an inch. So we have 2/10, and then the dial here is what gives us our hundredths and thousandths place. So here we're at 13, so that gives us the 1/3, right, in the hundredths and thousandths place, hence our correct length measurement of 0.213 inches. Student runs an experiment to determine if the length of grass affects the time it takes to dry out. She's using the same type of grass in her experimentation, and she is recreating the same drought conditions throughout. Okay, which variable would be the dependent variable? Okay, be the time to dry out. She is controlling the type of grass in drought conditions to stay the same. She is changing the length of the grass on purpose, right, to see if that affects the time to dry out. All right, so here length of grass would be your independent, but time to dry out would be your dependent variable. Student makes this histogram, plus or minus 3 standard deviation histogram for the diameters of a set of tennis balls. From looking at this, what is the mean and standard deviation of the data? All right, we could easily see this. It's in the middle of the 3 bins would be our mean, which is 2.64, and the standard deviation, denoted by the Greek letter sigma, is just the width of the bins. And notice all the bins are 0.05 wide, hence the standard deviation. Okay. Follow-up question, right? Same graph. How many tennis balls were tested? There'd be 30 of them. Just look at the frequencies, right? 6, 10, 6, and 8. There were 80 data points or 80 tennis balls tested. Okay. Which variable in an experiment goes on the x-axis of an xy scatter plot? Okay. That'd be your independent variable. Remember, your dependent goes on the y-axis, and your controlled variables do not go on the graph at all because they are being kept constant. Okay. What would be the standard deviation for the following set of golf ball diameters? Okay. It'd be 0, right? There's absolutely no spread in the data. All right, the mean would be 1.7 inches. All the data is exactly on that value, hence no spread, 0 standard deviation. Student gets this position versus time data for a certain object. All right, according to it, what would the object speed be in the first 5 seconds? Okay. Remember, we found this from the slope of the position versus time graph in our cart activity. We also saw it in the bubble activity that we did. Here we go 25 meters in 5 seconds, rise over run, gives us a value of 5 meters per second. Same question for the last 5 seconds. Notice the object is not moving. It is staying at the same position. This horizontal line has 0 slope, so we have 0 speed. Okay. If you had 4 students getting together to design a wheelchair for a disabled person, what could they use to help choose the design? This was in your POE notes and IED notes, a decision matrix. You kind of list the key things you want your design to have, and you can rank all the features from different designs from the 4 students to settle upon a compromise, all right, a compromised design. Last question is for Algebra 2/POE only. What is the probability that 2 of the 5 students in your lab group were born on a Friday? All right, here's the Bernoulli equation, Bernoulli process. You do not have to memorize it. It will be given to you. The key thing is to identify all the variables. There are 5 total trials because there's 5 students. X would be 2, the fact that we're looking for 2 to be born on Friday. The probability of that outcome is 1/7, right? There's 7 days in a week. The probability of it not occurring is 6/7. And if you work through the formula, work all your numbers through, you'll get to approximately 13%.